Hello and welcome to this video about financial maths. In this video, I'll be discussing how to calculate basic simple interest, compounding interest, and find out a return on investment. What first needs to be established is an understanding of the basic functions here, because when they're noticed inside a formula, to be able to understand what they mean is crucial. First here, I'd say A is usually how it's represented in a standard notation. A in financial maths is your end amount, what you're gaining from the process of your interest. And next, you'd have to consider your interest rate, lowercase r, if you're doing a word problem, or also if you're being offered it by a company or a bank or an organization. This will usually come as a percentage. Number of times compounding. Now this is only applicable for compounding interest. All of this here typically has a time period or time frame in which these processes will take place. That would be represented as T. The basic formulas are as so. The return on investment I'll cover later. Simple interest calculations and then your compounding interest calculations. So that simple interest calculation would have the A for the final amount, and that would be equal to your principal value, what you put forward, you set forward, and you're investing, and that would all be times 1 plus your interest rate, which will always be divided by 100 to find you that decimal, times the time period. Now this is for simple interest. It's not applicable to compounding interest, though there's a similar formula with slightly varying functions, but here that compounding interest formula would just come as so. So it'd be the same with your final amount. It'd be equal to the principal times something in a bracket, except there is an exponent on the outside, and that is considering how many times it's compounding and over what period of time. So here's your principal, and then inside that bracket then would be 1 plus your rate, your interest rate, and that would be, you'd have that come as a decimal. So just bearing in mind with both calculations, that would become a decimal. And then that rate, that interest rate then would be divided by the number of times it compounds. Just being careful here. It's important to note that this could be over a year, annually, it could be half annually, it could be every quarter year, so it varies depending on what real life scenario. That will be considered later. The interest rate divided by the number of times that it's compounding, and then there's a closed bracket there, exponential by, so those are the basic interest calculations. Just imagine now you have an uncle who is gonna give you $1,000 since you finished your final year of MYP, and you're going into DP, and then he's given you that 1,000 and you're going to invest it over a time period of 2 years. He comes forward to you and he says, well, you've got 3 banks. They all offer different interests. And these 3 banks offer different interest rates, different compounding frequencies. One is simple and the other 2 are compounding. How am I going to evaluate each one for their strengths? He's giving you $1,000 to get you through the 2 years, the DP program. So bank 1 is offering you a compounding interest at 10%. That would then come in to here, the compounding formula. What we know is that we're given $1,000 to invest. Say we're investing all of that $1,000 over a 2-year time frame, 10% interest rate, and it compounds monthly. Given all of those factors, you'll be investing your $1,000 as your principal value. That will be multiplied by, in brackets, 1 added to the interest rate made into a decimal. So in this case it will be 0.1 since the interest rate is 10%, and then that's all divided by the number of times it compounds. Since it's compounding monthly, over a 1 year time frame, it will be compounding 12 times. Now this n, this is always set to be designated for a 1 year time frame. So that will stay as 12 for now, since it's compounding monthly. And then here is where we make that adjustment considering the time frame. Number of times compounding multiplied by the time frame. Now this is an example of a compound interest formula with every variable filled in accordingly with the factors that have been provided. What then that will now allow us to do is look at how much money we will have after 2 years using this blueprint. In here you will have 1.0083 as a recurring decimal, and this would be exponential to 24 with your 2 year time frame. You can put that in a calculator. Your A value would now be $1,220.29. This is what you'll be getting investing in Bank 1 after 2 years. Bank 2 is offering you a 10.2% interest rate, but it compounds semi-annually, so every half year, twice a year. What we can plug in immediately now is main value multiplied by, in brackets, 1 plus the rate as a decimal divided by the number of times it compounds, all to the power of, immediately that would be 4. And for that bank, your final value after 2 years would be $1,220.14. And now that's your value for bank number 2, which you'll be left with after 2 years. Then finally, you've got your final bank 3, which is offering you a simple interest program with an 11% interest rate, and it's not compounding. So we'd be using this formula instead, the simple one, where we can plug in immediately our values of our principal of 1,000 in brackets 1 plus our rate as a decimal 0.11 times the 2 year time frame, your time period. That's meant to be a closed bracket. And then you will see that once you calculate it, you'll be getting your final value after 2 years as $1,220 on the dot. Now, from what's been demonstrated, the main playing factor here with what affects the final value after interest calculations is not necessarily the percentage, but in most cases the number of times it compounds. Because what we can see from here is that Bank 1 is offering the best program in terms of profit, because now considering the answers that we've found is that you'd be gaining $220.29 for Bank 1, $220.14 for Bank 2, and then $220 for the third bank. And that indicates just there that Bank 1 was offering a compounding rate that was more frequent than the other banks, and then that essentially made it so that that outside exponent was greater. And that outlines sort of that compounding interest on most occasions is much better than a simple interest program, because you'd be gaining 29 extra cents in Bank 1 and then 14 extra cents in Bank 2 in comparison to a simple interest. If you were to invest in that bank again for another 2 year time frame, this then would become your principal amount. That means now that you're putting this in here, you'll be profiting exponentially after that 2 year time frame with Bank 1 more than you would with Bank 2 and Bank 3. So now we'll be covering return on investments. And your return on investment is typically calculated in a percentage, to which extent you can go then and compare it to a set of other contenders for your trusted, loyal banking company. And that calculation would be your net income divided by the cost of your investment. Okay, now, say for example, you have a friend and you're investing 1,000 for your friend because they're trying to set up their own business. And then basically what they're saying to you is that they will be giving you, after 2 years, $1,230. That would mean your return on investment there would correlate with your net income after 2 years, which will be $230. That would be your net income value. That $230 net income, the cost of your investment, which was $1,000, that would mean then that it would be a 23% interest rate after 2 years of your investment. A return on investment is crucial for analyzing your best possible outcome when you're considering a variety of different organizations. Your friend here is giving you a 23% interest rate after 2 years. So then to compare them with the other banks' interest rates, the first one was 10%, the second one was 10.2%, and then your third bank was 11% with a simple interest. After 1 year, since these are over the 1 year time frame, that percentage then would be an 11.5 interest rate. But there's a big risk here involved, given your friend may not be a part of a professional company